Thanks a lot, everybody, for joining in. My name's Craig Hardner. I'm a Principal Research Fellow at the Centre of Horticulture Science, and I'm going to be facilitating today's presentation seminar. Next one, Matthew. As you know, we've got Matthew talking about the evolution of agriculture and food science. I'll just use this opportunity to say that, oh no, let's please go to the acknowledgement. I do want to acknowledge on behalf of us, the University of Queensland acknowledges the traditional owners and the custodianships on the land in which we meet. We pay their respects to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognise their valuable contributions to Australia, the global society, and to University of Queensland. Next slide, please, Matthew. Just as some housekeeping, first of all, I welcome you to the Coffee Science seminars. It's great we've got Matthew kicking off this year's season, and the Coffee Science seminars are an important way of communicating our research, both internally and externally. For example, all of the seminars are recorded and put on to YouTube, and a number of them, most likely Matthew's included, get large hits on people reviewing them. So this year's science seminars will be held fortnightly, and we need people interested in presenting their work. For example, we've got a space free on the 16th of April, which is the next seminar. So I'd encourage people to get in contact and arrange presenting their work. This slide is just to let you know that our seminar is going to go from 11:30 to 12:30. Matthew's going to talk for some of that time, and then we're going to have opportunities for questions and answers. It's important that we use the question and answer tab rather than the chat tab. Those questions in the chat tab, as important as they may be, I'm going to bring preference to the chat the Q&A tab. So please put them there. Can you move to the next slide, please, Matthew? So I'd like to quickly introduce Matthew, Professor Matthew Morell, Director of QAAFI. Matthew started his career at CSIRO and then moved to Erie as a Director of Research there. He joined QAAFI in February 2021 as the Director. So Matthew, could you move to the start of your presentation, and I'll let you take it away. Thank you.
Okay, thanks a lot, Craig, and great to be able to start the seminar series for this year. I'm going to touch on research imperatives, I think at a fairly high level in terms of global agriculture and food needs, talk a little bit about what we're doing at depth in QAAFI and UQ, and then come back to talk about some of the ways in which we're trying to work at a programmatic scale to really address some of the major challenges of our times, and then do a little bit of crystal ball gazing about the future and what some of the key opportunities for our staff and students might be into the future. So very happy to take any questions that pop up during the talk through the mechanism that Craig identified. So look, I'm going to start at a high level and just to really note that I wanted to remind ourselves that one of the biggest challenges facing our food and agricultural system is still the massive challenge in feeding an additional 2 billion people over the next 50 years, until we get to that point around 2070 odd, where we have peak population growth. And in the last decade, this question of food security in the face of population growth seems to have somewhat slipped off the radar as one of the biggest global challenges that we face. We've been perhaps consumed by more chronic short-term problems than some of these incremental problems that we face. But we have had some telling reminders of this challenge. We've seen the impact of COVID on supply chains, the impact of the Russia-Ukraine war, particularly on the wheat market, and the ways these events have brought food security to the fore again that were really unthinkable just a few years ago. So we do remain vulnerable to combinations of threats from climate emergencies, from wars, from disease. So if we think of in terms of a just-in-time management of global food security, it's really a pretty precarious situation for humanity. Looking at the past, through the Green Revolution and continued investment in agriculture and food innovation, we have shown that in the absence of these types of major global disruptions, we can meet the food security challenge. But I would comment that even this was achieved with insufficient attention paid to the environmental and societal costs of achieving those ends. So as scientists, I now see our greatest challenge is to do the science and create the solutions that simultaneously provide adequate nutrition for the world's population and protects our environment. This, to me, is the defining challenge of agriculture and food over the next 50 years. All right, so a look at the UN's population data shows that the food and nutritional security challenge is not uniform globally. Population growth over the next 50 years will be largely driven in sub-Saharan Africa, North Africa, Central West and South Asia. In contrast, in East and Southeast Asia, populations are predicted to decline after 2050 and to some extent contract in Europe and North America. Growth in Australia and New Zealand will continue, largely fueled by migration. In agriculture and food supply systems, this leaves us with quite different challenges in different regions, in the labour resources available to grow food, in the need to distribute food and trade food in ways that makes food available to all of those who need it. I'm sorry, just had a slight hiccup there. All right. So our food systems will need to adapt to meet the nutritional needs of predominantly young populations in Africa and Central Asia and of ageing populations in Europe, North America, East and Southeast Australia, and of course in Australia and New Zealand. Those markets are likely to have very different needs for information on the provenance of their food and the way it's produced and processed. So I want to just return to this question of complacency about food security. Indeed, as I mentioned before, less than a decade ago, we were really told that food security had been largely solved. But more recent data shows that there's still a worrying increase in food insecurity, and it centres, as we might expect, on sub-Saharan Africa and Central and South Asia. This comes at a time when international aid and research for development budgets are under severe pressure. For example, the entire CGIAR system is now smaller than the size of one medium-sized university in Australia. Smaller indeed than my institution, the University of Queensland. Surely more investment is called for to meet these challenges. So what then of Australia's role? Projections for the growth of Australian agriculture from the Australian Farm Institute shown here showing that the predicted march towards an industry worth 100 billion by 2030. And of course, some 70% of that production is exported. We are a demonstrably food secure nation. So our internal food security is subject more to questions of social equity and political and social will rather than capacity to produce. In the global context, Australia produces about 1% of the world's food. But given our export orientation, Australian production represents about 3% of total agricultural trade. We punch above our weight in the food security arena through several factors. Firstly, the food we produce feeds about 100 million people, largely in the global south. An inability to meet future export predictions will, of course, have economic impacts for Australia, but it will have a disproportionately significant impact on our regional trading partners and their people. Secondly, we've been a significant leader in innovation through our research and development focus in agriculture and food, and through the rigour that producing food for export in highly variable climates, with challenging soils, with a highly urbanised population, and with very low levels of subsidy. We've had to be good to survive. But I want to make the point that our performance in agriculture and food research and innovation is not just an internal matter. It's important to Australia's profile in the region and with our international trading partners. Our long prevarication over reducing emissions, the so-called lost decade, did us real harm with key partners, returning to a stance of seeing our agriculture and food innovation as a positive component of our national profile and soft diplomacy is important in the geopolitical context. It's therefore essential that we have an innovation system that supports industry achievement and our place in our region. So I've started with the global, brought it back to Australia, and now I want to ask the question, what can we do at the institutional level to support agriculture and food industries of the future, both globally and in the national context? By way of example, I will reflect on the journey that we're taking at QAAFI and in the University of Queensland to conduct research that simultaneously addresses two needs. Firstly, as a research entity that must conduct excellent research in order to attract support and talent, and secondly, to conduct multidisciplinary research at scale that can provide both comprehensive solutions to industry and society. Within UQ, there is now a rich ecosystem of discipline areas with strengths in agriculture and food. Through QAAFI, but also through our partners, the School of Agriculture and Food Sustainability, the School of Environment, School of Veterinary Sciences, School of Chemistry and Molecular Biosciences, and broader to the Faculty of Business, Economics and Law, and increasingly with the Faculty of Engineering, Architecture and IT. Our sister research institutes have important contributions through, for example, the strength in the interface between agriculture and the minerals industries in the Sustainable Minerals Institute, and in the deep molecular expertise in AIBN and the Institute for Molecular Biosciences. I'm pleased to say that at my time at UQ, collaboration across these areas of expertise has strengthened, with new leadership bringing new collaboration opportunities across the schools and institutes. And this is important because the new science requires us to reach out across the physical sciences, but also the social sciences, to assemble the research and the talent needed to solve the globally compelling challenges that we face. Within QAAFI, to dig even deeper, we have 4 interrelated research centres led by, in animal science, Ben Hayes, crop science Ian Godwin, horticultural science Nina Mitter, and nutrition and food sciences Yasmina Sultan-Bauer. And we have a focus on the challenges facing tropical and subtropical food and agribusiness sectors. In the next section of this talk, I'm going to look at a snapshot of the research conducted within our centres by QAAFI and our partners over the last year to illustrate the depth of the research expertise coupled with the focus on industry outcomes that is the core spirit of our research effort. In doing so, I want to highlight how new areas of science and technology are emerging that will shape the future of agriculture and food research. Before I want to move on, I want to pay tribute to the vision that underpinned the establishment of QAAFI as a partnership with the Department of Agriculture and Fisheries as it is now. In that vision, QAAFI has been able to gain access to expertise from within the department, to have strategic priorities that are strongly aligned to the Queensland Government and to our industries, and to access important facilities for research across Queensland. And I'm very pleased to say that in the past few weeks, we have signed a renewal of our alliance agreement, and we'll be going forward together in strength. So I don't have time to talk about all of the research that we're doing. So I'll quote my favourite singer, Paul Kelly, "So let the part tell the whole." So please take these as examples, not a comprehensive view of everything that we're doing. I want to talk about the work that is going on in leveraging genomic information. We're all familiar with the concept of Moore's law, which predicted that the number of transistors on a microchip doubles every 2 years with minimal cost increase. But since the first genomes were sequenced, the cost of sequencing genomes has declined almost 3 times faster than Moore's law. So there is, of course, a strong interdependency between advances in computing technology and genome sequencing technology that's truly spectacular. This fantastic increase in capacity is providing unparalleled opportunities in agricultural systems to turn the vast amounts of data available from cheap sequencing to critical information to support breeding and management in agriculture. So in these 4 examples, Harry Lamb and colleagues have shown how to sample cattle genomes to predict breeding outcomes at low cost and on the time frame of minutes. Nath and co-workers have sequenced the avocado genome, and that now allows the identification of key quality and disease resistance genes underpinning profitability. Ong and colleagues have shown how rapid microbiome analysis in animal reproductive tracts can assist management of reproductive health. And then returning to plants, our convener Craig Hardner and partners have shown how fruit quality genomic prediction can be used across diverse environments. These are just a representative sample of the way in which that deep knowledge of the biology of agricultural systems is being used by our teams in combination with genomic information to accelerate better outcomes. The RNA revolution. COVID brought the RNA revolution to everyone's attention through the BioNTech vaccine. However, this revolution has been underway for some time, perhaps just not so visible to the lay population. But it has been evolving and developing strongly, and the evidence for its future importance to agriculture is now becoming compelling, providing the means to precisely target pests, disease, diseases and weeds, as well as provide new methods for the effective vaccination of livestock. So these papers, the first from Tim Marnie and colleagues, canvasses the livestock RNA vaccine opportunity. In plants, the work of Degnan et al. Shows that double-stranded RNA application through bioclay not only prevents but cures fungal infection. And in the paper by Jane and colleagues, foliar application of bioclay is effective against whitefly, not only directly, but when the plant takes up the double-stranded RNA. This technology should reduce issues with residues, decreases the probability of resistance developing, and provides a generic approach to improving crop protection, even where there's no effective or environmentally safe synthetic chemical control available. It's one thing to have the genomic information that rapid advances in sequencing provide, but it's another to rapidly identify individuals and traits in a rapid and non-invasive manner. In assembling these examples, I was struck by the way our researchers' creativity has been used to use existing or emerging tools to derive critical information. So Cozzolino and colleagues have used well-established NIR technology, but in addition with chemometric analysis to identify individual animals, in this case goats, and to trace meat from those animals in a value chain, an important opportunity in the traceability question. Muradi et al. Have taken tail hair from cattle and using isotope analysis, identified those who are more feed efficient and linked this to the potential to improve breeding in a manner that minimises animal welfare issues. And finally, our ARC industry fellow, Dongju Zhao and co-workers have addressed the profound problem of analysing root performance from above ground using electromagnetic induction. There's a lot more to do in this space, but within QAAFI and across our partners in UQ, improving phenotyping capacity so we can take full advantage of genomic information is a continuing focus. We are acutely aware in Australia that we must find ways to improve productivity and quality under variable and in many years highly stress-inducing environmental conditions. There are a raft of proposed mechanisms through which performance under abiotic stress can be enhanced. In these examples, Wu and a collection of Australian global leaders in photosynthesis research have re-examined the potential for crop performance enhancement under a variety of environments and come to a combination of important new opportunities, but some at times sobering insights into the extent to which we can improve performance through manipulating photosynthesis. Andy Borrell and his colleagues linked genomic information on how the PIN family of auxin efflux carrier genes induces some of the causal mechanisms driving the stay green phenotype in sorghum and demonstrated their effect in transgenic studies showing that the SB2 PIN2 phenotype can increase grain yield under drought. And finally, it's also about our students. So in the bottom example, two of our PhD students, Shanice von Heften and Caitlin Dudley, working across the DAF breeding program, and our UQ colleagues have identified mechanisms for breeding mung beans that will have improved reproductive resilience under challenging climates. A very important development for helping us diversify our diet. On that theme of diversifying our diets, there's global recognition that while the big five crops for food, wheat, maize, rice, soybean and barley, are cornerstones of global food security. We need to progress additional crops that provide the opportunity to provide vital nutrition, utilise diverse production environments, and provide economic opportunity for Indigenous communities. In the top 2 studies, our CNAFS teams in the Centre for Nutrition and Food Sciences have shown how to prepare and process and protect the nutritional attributes of Australian native crops. And in the lower example, our Centre for Horticultural Sciences team have addressed the challenge of using modern breeding and selection strategies to improve the productivity and profitability of macadamia to support the continuing importance of this uniquely Australian crop. A couple of last comments about understanding how food is perceived. And in these examples, Su Wei Chin and co-workers examined the response consumers have to plant-based burger patties versus meat patties and showed that with our current understanding, the taste and flavour intensity profiles of the meat product could only be approached for the plant-based products through high salt contents. So at this stage of development, there's a trade-off between consumer perception of value of having a plant-based food versus undesirable high salt consumption. Changing tack, on the right-hand side of this slide, I found the work that Shahram Niknafs and colleagues have done in assessing taste perception in chickens to be fascinating, showing that there are very varied olfactory systems in avian species, and we really need to understand more about these systems to be able to optimise poultry feed and productivity into the future. So that's the end of my quick survey of discipline depth of our research. And as I said before, sorry to those of you who haven't been specifically acknowledged, but the lack of time available in a presentation like this means I couldn't cover all the fantastic work that our staff are doing. However, I do want to close on a more expansive note, recognising the key role that our science plays in not only making concrete and useful discoveries, but in imagining futures based on disruptive technologies. In this example, Ben Hayes and colleagues have reviewed the role that AI is already playing in breeding programs to address multiple simultaneous problems, interfacing with existing predictive breeding algorithms. But to challenge us further, they point to the potential of AI to work across existing data sources, perhaps silos in mixed farming systems, or across value chains to find solutions to the complex trade-offs that exist between genetic improvement, nutritional requirements, agronomy, and the environment to ensure that future agricultural performance is not only optimised, but optimised in the context of environmental sustainability. Coming back to that grand challenge that I outlined at the start. So I've had a look at the disciplinary expertise dimension of the equation, and I now want to look at what we're doing and should be doing in research at scale that addresses some of the greater challenges of our time. And look, as a general framing of the need in agriculture and food is to consider 4 general needs that industry has: for research that increases production and value, decreases costs, improves resilience and sustainability, and addresses some of the more difficult to address license to operate issues. The first example, I'm really going to focus on value addition with a component of decreasing costs, improving resilience and sustainability of our food systems. And this example is through the Trailblazer program. The Trailblazer approach was driven by the imperatives of our previous government's modern manufacturing initiatives and its 6 industry initiatives in energy, infrastructure, defence, aerospace, health and agri-food. And a secondary agenda was to encourage universities to adopt new ways of working with industry for direct industry development gain. In agri-food, we do have entrenched structural issues to address. Despite our bountiful agricultural surplus, too little of our agricultural production is transformed onshore into value-added products. We export commodities, not value. And we have a food industry that is one of our major employers, but is dominated by small and occasionally medium-sized enterprises, complemented by large multinational organisations that typically do their R&D and product development overseas. So Australia's Food and Beverage Accelerator was a product of our commitment to seeking funding to be able to conduct programmatic research at scale. And FABA, as it's more colloquially known, is led by Chris Downs, a research and innovation leader with an extensive track record in the food research industry in New Zealand and in Australia in CSIRO and in DAF. What sets Trailblazers apart, and FABA strongly embraces, is that it has a focus on clear industry development KPIs. It has industry-led governance, and it's established a robust and rigorous industry-led investment assessment and approval process. The deployment of resources in FABA is strictly treated as an investment, not a grant. And this is a not insignificant cultural change that's been embraced by the FABA research team. The investments in FABA fall into 4 programs: Innovation Pathways, Innovative Ingredients, Premium Food and Beverages, and the FABA Training Centre. And they're designed to reinforce each other in service of addressing the SME-dominated industry sector to access R&D that allows them to overcome technical and feasibility hurdles, access scale-up facilities, and build the skills and the teams that they need. I mentioned that FABA makes investments, not grants. The first tranche of investments, largely as set out in the funding proposal, have been closed. A second round of investments attracted over 70 EOIs from industry, and investments are being put in place with a pipeline of over 20 enterprises. Further investment rounds are to come, and if you want more information, please contact Chris using the email on the slide. So some comments about the Trailblazer model. It has undoubted strengths. Significant resources are directed to addressing a key industry development need. There is industry-led, low transaction costs governance. There's a real encouragement of direct industry involvement in university research, and research treated as an investment, not a cost. There is a process to build infrastructure, equipment, and industry research interfaces resources within the university participants for the future, training students and industry personnel, and bringing new thinking in innovation leadership to the sector. And finally, it encourages and exemplifies aspects of cultural change in relation to working with industry in the university sector. The main weakness that I see in the Trailblazer model, at the moment, it's a one-off program with a 4-year duration. And 4 years in changing an industry, in changing a university sector, is not a long period of time. So we really hope to see this model expanded on and continued into the future. My second example of programmatic research at scale was much more in the sustainability license to operate space. And that is the second major initiative that we've brokered in the last year or so with our partners, the COC for zero net emissions from agriculture. This initiative has been very much driven by the realisation that agriculture is a significant part of the challenge in achieving a low emissions future, and that this is fundamentally about the sustainability of our industry through continued access to international markets by addressing the licence to operate challenge that our industry faces if it does not reduce emissions in a meaningful way. The slides that are to come are from the pitch to the federal government to fund the CRC and set out key elements of the CRC bid. So I think there is a broad consensus that climate change is indeed one of the greatest challenges of our times, and agriculture is critical to meeting emissions targets, as outlined here. Some 16.8% of our national emissions come from agriculture, 78% from methane in livestock, 18% in nitrous oxide, particularly from crop residue burning and fertiliser use, and 4% from carbon dioxide from lime and urea use. A number of studies have shown us that current technology will not get us there, but inaction threatens productivity, market access, and growth. And if we have an ambition to approach zero net emissions by 2050 with a major milestone in 2030, time is running out. When we consulted with industry, as one has to do and needs to do in establishing a CRC bid, we had a very consistent message. We need, as industry, a go-to honest broker for leadership, expertise, and action. There's a lot of pressure from boards, from ESG investors, and from financial institutions on industry to explain how it's addressing the emissions reduction imperative. So this CRC seeks to provide national leadership to reduce the fragmentation. There are a myriad of small investments across the Australian research landscape in emissions reduction that need to be brought together into a more coherent story, a more coherent effort in emissions reduction in agriculture. And through this, to accelerate progress at scale. The research program being overseen by Ben Hayes and his colleagues from across the university and state government sector in partnership with industry has 4 major objectives around low emissions plant solutions, methane-free cattle and sheep, the whole question of whole farm and mixed enterprise systems analysis, and delivering value from net zero. And like all CRCs, it has an education, training, and an adoption imperative. So in this case, we do need to work to develop new specific solutions using deep research expertise that plug gaps in our ability to drive emissions lower. But we need to also combine that with cross-disciplinary and whole of system thinking to provide for comprehensive, or what we call stacked solutions that are affordable to implement. And these will be demonstrated to industry through partnerships around producer demonstration sites that show how these technologies work in practice. It is a big CRC, the largest grant in the history of the CRC scheme, with some $87 million of Commonwealth funding matched by industry and research agency and state government funding over a 10-year period. We have strong governance led by our inaugural chair, Deborah Cousins. We've been very fortunate to recruit Richard Heath as CEO, coming to us from the Australian farm industry and an outstanding track record in the agribusiness sector. And we have Ben, as I mentioned, from QAAFI, leading the research leadership team from across 10 universities, 6 state departments, and the Northern Territory government. But I want to also recognise the fantastic support that our business development lead, Oliver Frith, provided, and the QAAFI operations team headed by Michael O'Shea. But finally, there's no CRC without industry and our 16 major industry partners and 43 SMEs and grower organisations that were integral to the bid in providing their insights, their requirements, their definition of success, and their support. And this next slide shows you a snapshot of the many partners involved, and I won't dwell on this other than to say that it's been a fantastic experience working with them all. So to come to the CRC model, what are its strengths? Significant resources directed to addressing key industry development needs. Industry-led governance. 10-year funding provides a platform to really get stuck into it and develop and implement solutions. Again, direct industry involvement in setting the questions, but also in the participation in the research and the definition of success. Research, again, is an investment, not a cost. Outcome and delivery focused, and a commitment to training students, but also to be able to train industry personnel. Industry, in this case, doesn't have the time to wait for it to be upskilled through the evolution of students into industry. Existing industry personnel need to be trained to meet this challenge. If I were to say there's a weakness, I nominate that the incorporated structure involves significant transaction costs. Working with 73 partners to set up a major initiative like this is a time-consuming and difficult process, but of course, in the end, well worthwhile. But nonetheless, takes a lot of commitment and time. So I'm now going to move to the future. I'm going to perhaps start on a less happy note. So this graph shows the R&D funding landscape across the OECD nations. And you can see all the squiggly lines there are different countries, and you can go to their website and see them if you like. But the black line is the average across the OECD. Unfortunately, the red line is Australia's investment in R&D. And you can see that after almost reaching the average level in 2008, our performance in investing in R&D has slipped considerably over the ensuing decade. I don't think this is where we want to be, and it's not a way of supporting us to meet those global challenges for the future. So to come back and juxtapose the major challenge of feeding the world, increasing Australia's performance in the agri-food sector and our ability to export, and combining that with our track record on research investment, it does seem to me that we don't quite have our priorities right yet. So how can we build a stronger system for the future? I think we need to lift R&D spend to that 3% of GDP, not to be a leader in the OECD, but to be well entrenched in the middle ranks of that cohort, at least. The University Accord that was recently submitted to government as a discussion paper supports an aspiration for Australia to lift spending to 3% of GDP. There are also mechanisms under discussion that would link research to the imperatives of government and the creation of new and innovative industries through SMEs. These are all proposals. So let's see what progress there is towards implementing these decisions over the next year. We believe that the Trailblazer model, while all too short in duration in its initial implementation, provides an excellent addition to the Australian research landscape, bringing industry and university research together in a low transaction cost model. And we will be advocating for the future of the Trailblazer scheme and for the investment in FABA on a longer term basis. I've not really touched on the rural development corporations in this talk, and of course support their role as a key part of the agricultural research system. The RDC scheme is the one envy of the rest of the world that we have in this space. But I do note that they contribute to a fragmented pattern of investment at the project level. There are not enough opportunities for bringing together greater investment in collaborative and programmatic investment at scale, and looking at the entire production system, not just pre-farm gate, as many of the RDCs do. I want to leave you with two reasons to be excited. Right? So we have some fantastic opportunities, not just concerns about research funding to look at for the future. So here's our agricultural landscape. But I think the first reason to be really excited is the enormous opportunity that disruptive innovation brings to change the face of agriculture and food. So in the early part of this presentation, you'll have seen some of these research opportunities being exploited in genome editing, in RNA technologies, in artificial intelligence. There is more to be done in robotics, in situ and remote sensing. And in order to implement these new technologies on farms and in food systems, we need the connectivity that allows these technologies to be exploited for maximum benefit across our agriculture and food systems. But it won't be my generation of researchers that brings the potential of these disruptive technologies to full impact on the agriculture and food of the future. So let's look at some opportunities to develop the generations to come. And so I think we're very pleased to see a number of new initiatives coming to pass that will support the development of students, higher degree students, and encourage undergraduate students into agriculture into the future. So through the IRTG Centre for Accelerating Crop Genetic Gain with Justus Liebig University in Germany, we have a tremendous program to provide students with enhanced PhD training. We have the ARC Training Centre in Predictive Breeding that Lee Hickey and partners across UQ and Australia are developing that will really enhance the use of data and predictive technologies to enhance breeding and to train a new generation skilled in these arts. And both the CRC and FABA have PhD studentships that will enhance the effort in their areas, working again with industry. So collectively, these programs across UQ should train an additional 150 or so PhDs over the next few years. But we must develop students with new skills to meet future needs, and deep research excellence is perhaps not enough. So in this slide, I just want to make the point that we want to build on the discipline excellence of the research that we're doing and that I've outlined earlier in the slides, but we want to develop students with the so-called T-shaped skills, emerging researchers who not only have discipline-based expertise, but also have the skills and experience to meet the needs of industry and society. So in our students, we're ramping up the industry internship opportunities we can offer to allow students a chance to experience the questions that industry faces and its challenges, and also to work with government partners such as staff. We're working to develop a new generation of early and mid-career researchers who have more experience of working with industry and in leading and bidding for projects and participating in programmatic thematic research. Recently, we conducted a survey of where students from our Centre for Horticultural Science were employed. It turns out that about 30% of them are now academics, half of those in Australia and half overseas. 30% are employed by industry and 40% by the government sector. So we must prepare our students and early career staff for careers not just in academia, but in industry and government, leveraging their research training and their skills in evidence-based thinking for better outcomes for the future. So my final message: there really has never been a more important time to be an agricultural or a food scientist. Agriculture and food science is central to pressing global challenges that are not resolved. Agriculture and food science are constantly evolving to embrace new areas of science. The interface of data, analytics, and AI is changing our world, and we need to work at scale with longer-term funding. As I've mentioned through this talk, agriculture and food science is a capacity that Australia should be proud of and provides to the world. So I see the future being around great people, bringing expertise, diversity of thought, and creativity. These people for the future are the key for industry, government, and indeed academia. So Craig, I will leave it there and hand back to you.
Thanks very much, Matthew. And I think it's a great setting for the rest of the year in the Prof Science seminars. If everyone that you highlighted there was willing to come along and share deeply about their work, I think we'd have a really exciting session. So I appreciate the big picture as well. We're open for questions, and perhaps I can start with one. And I guess it's in a way it's getting back to your favourite singer, Paul Kelly, who talks about from little things, big things grow. So I'm interested in how that we can, with this, ideas of operating at scale and seeing big opportunities, also be encouraging the investment to help the smaller industries grow.
Yeah, and I think given that you're in the horticultural science area, Craig, it's clearly close to your heart. And it has been a difficult question where we've had the challenge of funding research at scale, where we have 160 horticultural crops that are produced in Australia. If you take a levy from each of those crops, it doesn't really pay much of the bill in terms of doing research at scale. So look, I think there is an opportunity, and perhaps one of the challenges that I see with the RDC scheme is that we have 15 RDCs. We have very many common problems, but we have 15 silos investing in those RDCs. We have had one effort to try and produce a more joined up investment vehicle that is still developing. But I think we could make much more use of collaboration across the RDCs and across those sectors in horticulture, for example, to address some of those bigger questions at scale. And look, some of the investors down the value chain have really escaped having to put their hand in their pocket to fund the research as well. So perhaps there's an area that needs to be looked at in terms of not just farmers paying the costs of research for production into the future. I know that's they're fighting words in a highly competitive industry, but look, an important need for us to think about more into the future, Craig.
Sure. Thanks, Matthew. Okay, so we have, and again, encourage any questions up here. So we've got one here. Could you give us do you know the expected growth of the RNA technologies in agriculture? Have you got a feeling of where RNA may go?
Look, I think we've been in a phase where, look, some of the pioneering work that's been done in QAAFI with the bioclay technology, for example, has shown the potential of using RNA more broadly, but it's been a bit of a chicken and egg situation with the costs of RNA production and availability, and also solving some of the, or addressing some of the regulatory hurdles. I think it's been a really interesting period because we've seen the explosion in interest and investment in RNA technologies because of the COVID experience and the importance that RNA vaccines have played. And we've had investments in UQ, in the base facility, for example, at AIBN, to really expand our capacity to use RNA. And if we think of the sequencing and the Moore's law example, the more you use a technology, the lower the cost comes, right? So I think there's tremendous potential, not just from the efficacy of RNA as a crop protection agent, but because it really also helps us with some of the really difficult questions around emissions, around resistance build-up, and about the huge investment required to register new synthetic chemicals. So RNA has great advantages. I think in 20 years' time, it'll be a routine part of the agricultural landscape. It may still have some teething questions to resolve, but I'm very bullish on the future of RNA in agriculture.
Excellent. So I'd like to close with the last one. Thanks, Matthew. Great presentation. I'd like to add a bottom horizontal bar to the T diagram, making industry, society, and research. The bottom horizontal bar could be cross-disciplinary research expertise. Your thoughts on drawing another line there?
Look, I think I'm not the most skilled in terms of my drawing talents, but I had intended to incorporate that thought really in that industry to society line. And yeah, having students and researchers who are able to make those linkages and work across areas of science is really important. But I guess you have to have your feet very solidly planted in disciplinary expertise, I think, to be able to really leverage that cross-disciplinary opportunity. So that's my perception. And I think that's what we can provide in an institution like UQ, is a really fundamental basis in terms of research expertise. And then as you develop your career, develop the capacity to work across systems, to work across areas of science, to work across sectors. And that's what I think makes a career in agriculture and food science really exciting. You can stay narrow, but I think there's fantastic opportunities, fantastic excitement in capturing that opportunity to work more broadly.
Great. Look, I'm going to close it down here. Thanks very much from all of the attendees. Do want to give a plug for the science seminars again. We've got the QR code off, but please just look up Coffee Science Seminars online. You'll get to the page. You get to them at YouTube to see any of the old recordings, and this one will be up sooner or later. And we'll look forward to the next one.